quadratic functions. We've done linear, we've done exponential, now we're going to do quadratics. The quadratic, if you remember, the linear parent function is y equals x. The quadratic parent function is y equals x squared. So let's graph it here. If we made a table of values, let's do some negatives, some positives, a 0, and see what's happening here. Well, negative 2, if we do y equals x squared, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So let's graph this. And it makes this U shape. Oh, totally missed those points. Maybe I should try that again. It makes this U shape, which is our, try again. This is our quadratic function. It's called a parabola. So quadratics graph as a U. In Algebra 1, we only do an up-facing U or a down-facing U. Algebra 2, you'll do sideways ones. So there's some important features of a quadratic, of this parabola. The vertex is the highest or lowest point. Also, this high and low point might be called highest. It might be called the maximum. Lowest, it might be called the minimum. And up here on the parent function, the vertex is a minimum, and it is the point 0, 0. That's an important point because you have this axis of symmetry. That's this invisible line, imaginary line, vertical, that cuts your parabola into two symmetrical halves, two equal pieces. So it's the imaginary line that cuts the parabola into two equal parts. Now, in Algebra 1, it's always a vertical line, and vertical lines only have an x. They're not functions. They don't have a y. So it's x equals, and it goes through the vertex. So it's the x value of the vertex. So on the parent function, your axis of symmetry is x equals 0, goes through the x value of the vertex. We know what a y-intercept is. Y-intercept is where the parabola crosses the y-axis. It's where x is 0, and then you have a y value. Well, on the parent function, it's still 0, 0. And the other really important feature besides vertex of parabolas is their roots. What you need to learn about roots is we call them 4 different things. They're the x-intercepts, which would be where the parabola crosses the x-axis. But the x-intercepts on quadratics are called roots, solutions, and zeros. So you need to know when I ask you for the roots or the solutions or the zeros, those all mean x-intercepts. You can have 1 or 2 or none. Our parent function only has 1 root, and it's the same as the vertex. Anytime you only have 1 root, it's going to be the same as the vertex. So root, where it touches the x-axis. It can touch twice, most parabolas will, or it can never touch and not have any roots. That would be a parabola that looked like this or this. It would never touch the x-axis. So your parent function has 1 root, and it is the same as the vertex and the y-intercept. It is 0, 0. We know that the domain is all the possible x values of a function, and we know that the range is all the possible y values of a function. For our purposes, in Algebra 1, we're only going to look at parabolas where the domain is all real numbers. Now, the range depends on if it's a maximum or minimum. So this one is going up forever. It has a low value and then keeps getting bigger. So the range is greater than or equal to that vertex. That's your low point. So your range value is the y value of the vertex. So let's look at some examples on the next page. Now, the easiest way to do these is with Desmos. We could do a table of values, but we wouldn't be quite sure which values to use. We would have to kind of play with it to find the vertex. If you will use Desmos and put in, what's our function? X squared plus 2x minus 8. If you will go to Desmos and put in x squared minus 2x minus 8, then it will graph it for you. And if you touch or hover over the vertex, it tells you what it is. Same thing for the roots, the x-intercept. It tells you this one has 2 roots, crosses the x-axis twice. So I've got, for my vertex, 1, -9. Or was that -1? I've already forgotten. No, it was 1. I don't think I put my function in right, did I? Nope. That was a plus sign. So there we go. Our -1, -9. And -4, 2. So it's right there. Your roots are -4, 0, and 2, 0. And the vertex and the roots are enough for you to graph this function. Y-intercept, it's easy also to find that on Desmos because you hit the gear shift and make a table of values. When x is 0, y is -8. Axis of symmetry. X equals, it's always the x value of the vertex. So -1, domains all real numbers. Range, y is greater than or equal to, your low point is always the y value of the vertex. So this would be how you would use Desmos to graph and to answer all of these questions.